Hello and welcome to Maths with Udom. My name still remains Mr. Okon Udom, your online mathematics tutor. You are welcome to today's class. Today we are going to look at reduction of fractions into their lowest terms. Reduction of fractions into their lowest terms. So let's start. Okay, reduction of what? Fractions into their lowest term. When we talk about reduction of fractions into their lowest terms, we are talking about reduction of improper fraction into their lowest term, okay, into proper fraction. That's another way of saying that. How to reduce improper fraction to proper fraction, or reduction of fractions into their lowest term. And we have two methods we can use to solve this problem. We have the inspection method, and we also have the prime factorization method. What is the inspection method all about? It has 3 steps. If you want to use inspection method, okay, we have 2 methods. Method 1 is called the what? Inspection method. Okay, while method 2 is called the prime factorization method. Okay, inspection method and prime factorization method. Okay, now for you to use the inspection method, we have 3 steps involved. Step 1 is to look for common factors of both the numerator and the denominator. Look for common factors of both the numerator and the denominator. Then the second step is that you divide the numerator and that denominator by their common factors. Divide the numerator and denominator by their common factors. And thirdly, you repeat the process until there's no more what? Common factors that can go through both numbers. Okay, so that is how to do the inspection method. Okay, and then for prime factorization method, we are going to write each of the numbers in their prime factors. Okay, you spread out the number, writing their prime what? Numbers. Okay, and then you start dividing the numbers. So let's add this example. Okay, the example is that we are going to express the following fractions in their lowest terms. Okay, let's have these examples. Express these fractions in their what? In their lowest term or terms. Okay, the first example right there is 22/8. Let's have some second example, which is let's have 21/7, and let's have our third example, which is 26/78. So let's have these 3 examples. Okay, let's express the following fractions in their lowest term. Let's reduce them in their lowest term. So let's start solution. Let me start with method 1, which is what? Inspection method. Okay, I'm going to be doing the 2 at the same time. Okay, so we have 22 divided by 8. Now for the inspection method, I'm going to look for a number, okay, a common factor that can go through 22 and 8 at the same time. Okay, so what number can go in 22 and 8 at the same time? We can see that 2 can go. So let's have 22 divided by 2. And let's have 8 divided by 2. 22 divided by 2 will give us what? 11. And 8 divided by 2 will give us what? 4. Okay, so this is an improper fraction. It's still an improper fraction. So how many times can 4 go in 11? Okay, we have what? 2. Remember what? 3 divided by 4. Okay, so this is, we have reduced this number into its lowest term. Now, if I want to use second method, which is what? The prime factorization method, I'm going to have 22 divided by 8. What are the prime factors of 22? I'll have 22, 2 multiplied by 11. How do I get that? Okay, let me do it here. We have 22. Okay, what can go? 2. 2 in 22, 11. What can go? 11. 11 in 11, 1. So 2 multiplied by 11 are the prime factors of 22. So 2 times 11. The same thing with 8. I have 8. What can go? 2. 2 in 8, 4. 2 can go. 2 in 4, 2. 2 in 2, 1. So these are 2 times 2 times 2 are the prime factors of what? Of 8. So I have 2 times 2 times 2. So from here, the numerator and denominator, what can cancel out? 2 can cancel out. What is left? 11. They have 2 times 2 will give me what? 4. How many 4 can go in 11? 2. Remember what? 3 over 4. You can see that we got the same answer for both what? For both inspection method and prime what? Factorization method. Let's quickly move to the second example. Example 2. So for example 2, what do we have? 21 divided by what? By 7. Okay, so we have 21 divided by, at least let's look for a number that can divide through 21 and 7 at the same time. That is a common factor. What can go through? I think 3 can go through. 3. I think it's 21 divided by 20. This number is 21 divided by 27. Sorry, divided by 27. Okay, divided by 27. Okay, 3 can go through 21 and 27. Okay, so let's have 27 divided by 3. Okay, now 21 divided by 7 will give us what? Then 21 divided by 3 will give us what? 7. And 27 divided by 3 will give us 9. Okay, will give us 9. So this is the answer. Now let's also use the prime factorization method. To use the prime factorization method, I have 21 divided by what? Divided by 27. Now for 21, what can go in 21? 3. Now 3 times 7 is 21. Then 7 can go. 7 is 7, 1. So I have 7 times 3 as my prime factors. So we have 3 times 7 divided by, let's do the one for 27. For 27, what number can go? 3 can go. How many 3 can go in 27? 9. How many 3 can go in 9? What can go? 3. 3 in 9 is 3. What can go again? 3. 3 in 3, 1. So these are the prime factors. 3 times 3 times 3 are the prime factors of 27. So I will write 3 times 3 times 3. So what can divide through the numerator and denominator? 3 is common. So 3 cancel 3. So what is left here is 7. Then 3 times 3, I will get what? 9. You can see we got the same answer here also for both the inspection method and the prime factorization method. Quickly, we'll move to the third example. before our assignments. So the third example, we have 26 divided by 78. 26 divided by what? 78. Okay, so from here we have 26 divided by, I think 2 can go there, and 2 can also go in 78. Okay, so how many 2 can go in 26? We have 13. At least 2 in 2, 1. 2 in 6, 3. How many 2 can go in 7? Okay, 3. Remember 1. How many 2 can go in 18? 9. Then from here, 13 can go in both the numerator and denominator. So we divide numerator by 13. We also divide denominator by 13. 13 divided by 13, you have 1. 39 divided by 13, you have 3. Okay, that is the inspection method. Then the prime factorization method. 26 divided by 78. What are the prime factors of 26? Let's get it out. 26. What can go? 2. 2 in 26, 13. What can go? 13. 13, 13, 1. So we have 2 times 13 for the numerator. The denominator, 78. Let's get the prime factors. Okay. How many 2 can go in 7? 6. How many 2 can go in 18? 9. How many 2 can go in 7? 3 rather. How many 2 can go in 7? 3. Remember 1. How many 2 can go in 18? 9. What can go again? Nothing. 39. 39, 39 is what? Is 1. So what are the prime factors? 2 times what? 39. So from here, what do you notice? 2 and 2 can cut or go through each other. You cut 2, you divide 2. Okay, so what is left? We have 13 divided by what? 39. So 13 can go through. So 13 here 1, 13 here 3. So our answer is 1 over what? Over 13 using the inspection method. Okay, so we have that as our answer. That as our answer. So I want to give you assignments. Okay, so let's have our assignments quickly. So the assignment is that we are going to let's have our assignment. Express the following. The following fractions. In their what? In their lowest terms. Number 1, let's have 25 divided by 100. Number 2, 10 divided by 225. Number 3, 26 divided by what? 84. And lastly, number 4, 14 divided by 216. So this is your assignment. Okay? So this is your assignment. Now, we have come to the end of today's class. But before then, kindly like this video, drop your comment in the comment section, share this video to all your friends all over the world and families all over the world, and then click on the subscribe button. Remember, the only way to know mathematics and become mathematics guru is to keep on practicing. You practice every day and then you become better by the day. Until I come your way again next time, my name still remains Mr. Okon Udom, and I'm saying to you, remain mathematically sound. See you in my next video. Bye for now.